Welcome and thank you for joining this session about semi-plug-in application. This application has many names and you've maybe already heard water loop or semi-distributed or micro-distributed systems. This is all the same and this is what we're going to talk to you about today. My name is Mathilde Pedersen and I will be hosting the session today. And let me just briefly take you through the topics that we'll be covering. So firstly, we will have a look at the application, from the very simple application with just a dry cooler to the more advanced one using, for example, a chiller or heat recovery. Then we'll do a specific focus on the display case, where we will first look at the refrigerant and then go into the different components that are used in the refrigerant circuit. And then we will move on to the water loop system with the pump station, water valves, and so on. And finally, at the end of this session, we have a Q&A where if you have questions for some of the experts that I have with me here today, then you can ask those questions. The experts that I just mentioned is Hans, who will be presenting about water loop. Then we have Einar, who will be talking about the controls, and Stefan, who will be talking about the application and also refrigerants. So first, Stefan, over to you to talk about the application.
Thank you, Mathilde. Yeah, if we talk about supermarket applications today, then let's start talk about plug-in cabinets. You all will know these relatively small cabinets which have a complete refrigerant circuit inside and only need a socket to plug it in. You will see it normally in relatively small stores, but sometimes as well in let's say, standard supermarkets, since you can move it easy around for special offers, for example. A big disadvantage is these cabinets will blow the whole heat into the supermarket back. If we talk about the next category of cabinets, that would be the remote cabinets. There you have a number of cabinets inside the market. You have a machinery room with a rack system inside and a condenser on the roof. And all the components are connected via copper pipes filled up with refrigerant. And the heat will be directly removed to the ambient via the condenser on the roof. The third category, and that's what we are coming to now, that's a semi-plug-in. You can see it on the slides there. That's a plug-in cabinet. It looks more or less like a remote cabinet. On top you have the complete refrigeration circuit. Of course, inside there's an evaporator. Above there's the rest of the circuit. And these cabinets are connected to a water loop system. You can see it better in my next slide here. You can see the cabinets are connected via these water loops through a pump station to a dry cooler or chiller. Why are we doing that? What is the advantage by doing that? This type of cabinets has a low amount of refrigerant inside. You need less refrigerant in the shop. The cabinets are factory filled and hermetically sealed, means you can use flammable refrigerants. The pipes are filled with a water glycol mixture. That makes it easier to install. And you do not need a machinery room. Compared to plug-in cabinets, you can put more cabinets into a shop since the heat will be removed directly via this dry cooler outside. Now let's talk more about this water loop. My colleague Hans-Ole Mathisen will later on go deeper into that, but let's talk a little bit about that. It's important to remove the heat which is produced by the compressor up in the box on top of the cabinet, inside this box. And this compressor has a maximum allowed condensing temperature of approximately 55 degrees C. And to achieve that, you would need around 47 degrees C water supply temperature, which will be possible in most places in Europe by using a dry cooler only. At the lower temperature end, you need to have a pressure ratio of approximately 2. That means the condensing pressure has to be around at least 2 times the evaporating temperature. That could be a little bit challenging at low ambient, winter time, for example. Then you have to do some measures, like, for example, if you have a look again on the screen, if you slow down the speed of the fans, you can keep the temperature inside the system, or you can throttle the water flow through the condenser by using water valves like our WVO. A third possibility would be to use a three-way valve, which is controlled by the MCX and will mix up the supply and return water. Of course, you can, instead of using a dry cooler, you can as well use a chiller. In this case, you can keep the cabinets always at its best efficiency, but of course it has to be decided from case to case whether it makes sense to use a chiller or a dry cooler is sufficient. Additionally, you can use heat reclaim like you can do in other types of supermarkets. Will, due to the lower temperatures, not be that efficient like it is, for example, with a CO2 installation. Thank you, Mathilde.
Thank you, Stefan. We won't let you go just yet, because now we will have the focus on the display case, and there we will start with the refrigerants. And this I hope you can also tell us a little more about.
Yeah, sure, Mathilde. I can do that. Refrigerants. You can, in principle, you can use everything you use today in supermarkets. Of course, it should not be banned by the F-gas regulation, and you should try to get a refrigerant with a GWP below 150 to make it future-proofed. But you might know that most refrigerants with a GWP of below 600 are flammable, or at least mildly flammable, or have a high pressure like CO2. This flammable refrigerants, and here let's talk about propane, has to be covered by a standard. If you build your cabinet, you need to have a standard to cover all the safety aspects. And here the IEC 60335-2-89 comes into play. And you might remember that in the past it was allowed to put up to 150 grams of refrigerant into the circuit. And it might be clear for all of you that 150 grams might be not enough refrigerant. If you have a look on a 3.75 meter food retail cabinet, there you would need approximately three refrigerant loops to get the cabinet up and running. With the last revision of the standard, you can go up to 500 grams of refrigerant. But as you can see here, for refrigerants above a certain limit of 4 times the lower flammability level of R290, that would be this 150 grams, there's a minimum room size floor mentioned for the unit. You have to put, for example, such a symbol on the cabinet where you state the room area you need. And you can see in this diagram that above 150, the demand for the room area increases up to approximately 24 square meter. That's a minimum needed room area if you go for propane, but that should not be a problem in standard supermarkets or discounter stores. The last important point for that is that all components have to be hermetically. You cannot use, for example, components with flare connectors. That it was, Mathilde.
Thank you, Stefan. Now I can see you mentioned here the IEC standards, but we also know there's a lot of EN standards. What is actually the difference between these two types of standards?
Okay, important to mention that, Mathilde. It's an IEC. That means you cannot use it directly in the European Union today, but it's in progress to get it approved for the EN. For now, it's possible to use this IEC standard and develop the cabinets according to this IEC standard and get it approved by authorities like TÜV, for example, that everybody will know.
Very good. Thank you very much, Stefan. So now we'll move on and look at the components that we're using inside this refrigerant circuit, and with a specific focus on the propane refrigerant circuits. And here we first have a recorded video from our colleague Paolo, who is going to talk about the brazed plate heat exchangers.
Hello everyone, thanks for joining the Cooling United event. I'm Paolo Canal, Product Manager for Microplate Heat Exchanger. I'm to introduce you the dimple design technology for air conditioning and refrigeration, especially for semi-plug-in system. Before we go in detail in the new product, let me explain the dimple design that we have released a few years ago and now widely implemented in the new models. This is the heat plate characterized by this small corrugation. All dimple put together allow heat transfer on a large surface, but on top of this The numerous contact joints render a strong and reliable structure for a lighter product. The latest technology is the Z design. It was developed for evaporator function, but it can give outstanding performance also in condenser mode, thanks to his particular fluidodynamic flow, where the dimple pushes the refrigerant to occupy all the surface, keeping high the heat transfer coefficient. But the main values of the dimple is the extremely low hold-up volume, very important when the application is used with flammable refrigerants. Now, I want to talk to you about the availability for semi-plug-in system. From our big product portfolio, I've selected these 3 models. Based on the application needs, we can offer the best solution. The H17LCZ is the latest product launch. Its compactness is the main values you can bring from this product. In less than 18 centimeters, you can cover the wide capacity range. The H22C is a good compromise in between compactness and performance, and it can guarantee a very low water pressure drop. The H30CW is the top in terms of performance, and it can guarantee an extremely low hold-up volume. All models are qualified to operate with all refrigerant types, also A2L and flammable gases like propane. And moreover, all models are available in a dual circuit back-to-back, like this one, where we have 1 water circuit and 2 refrigerant circuits. Very useful when for design constraint or for refrigerant reduction, you have to split in 2 circuits the system. So here we are at the end of the presentation. I will be pleased to reply to your question and help you to take the advantage of the integration of our microplate and other Danfoss products in your system.
Thank you, Paolo. And now we're going to talk about the electronic controllers. And Einar, I can see you have brought some different electronic controllers with you today.
I did. We have 2 different platforms of controllers. We have the CC210 controller platform, and then we have also the 460 platform. The difference between these controllers and the ones we are using for remote cabinets is that they have sealed relays. And since the relay is the only spark-giving component in a controller, we need to have them sealed. And we even have a third-party report, test report for all the relays we are using here, which we can hand over to the OEMs for him to do his authorization of the cabinet easier. So
that's great. So safety first, I can hear.
Absolutely.
Yeah. What is the difference between the controllers you have here?
Yeah, this is a controller which is used for plug-in cabinets or even for more basic semi-plug-in cabinets, controlling 1 or 2 compressors. The 460 is with more functionality, more features, and if we are looking on the screen behind here, we can see that we have different applications, so we can control 2 compressor steps, sequential or cyclic, or we could set it up in an application where we're controlling a variable speed compressor by means of an analog output. So these are the applications we can set up in the controller.
Okay, we heard before that Stefan was mentioning that for especially the very large display cabinets that we sometimes have free refrigerant circuits. Are you able to manage that with these controllers?
Yeah, the way we see our OEMs using it is that they have 2 compressors connected to the first output, compressor output, and then the third compressor to the second output. And then we have a functionality that we are monitoring the water temperature, and if the water temperature is getting too high, then we can actually reduce the compressor capacity by taking out the third compressor, or with the variable speed, we can reduce the capacity or the speed on the compressor, so we are not, so we are running to death, so to say. So that's the way we can control it, and thinking we have a very nice package here for R290 applications, semi plugins.
Thank you. Thank you very much, Einar.
You're welcome.
So let's have a look at some of the other components that we are also offering. Let's take the first one here, the heart of the system. This is the compressor. Danfoss is offering a wide range of propane reciprocating compressors. We have both fixed speed, variable speed for medium temperature and low temperature application. In low temperature, our range goes from about 100 watts, and for high temp up to about 2.5 kilowatt. And in fact, one of the cases we have here behind us is a 2.5 meter case that we are running with one of these compressors, variable speed, in one refrigerant circuit, going a little bit above the 150 gram in refrigerant, so referring to the IEC standard that Stefan was mentioning before, but we are using these compressors for this. Another component is the temperature sensor, and in the past we had the black one. Now we have 5 new colors, so making it easier for the servicing so that each location of the sensor has a specific color. Besides that, these sensors are mounted with a PT1000 sensing head, so securing a very fast response time, but also there's no need for the yearly calibration. For the mounting, the sensing head has a curve here, so it's easier to mount on the pipe, as well as a clip. And for the panel mounting, you can simply just use this clip for mounting it. If you want a customized cable length or sensing element, then we are also able to manage that. Next component that I have here is our Danfoss Eliminator, the filter dryer. This is a 1.5 cubic inch filter dryer, and as you can see, it is super compact, so it is very good for a refrigerant system with a low charge. We find this a very valid alternative to the pencil filter dryer, where you sometimes can maybe find some unwanted particles being introduced into the refrigerant, and this you avoid with the Danfoss solid core technology, which makes sure that your refrigerant stays both dry and clean. The other components that we have here is our expansion devices, and this many of you probably already know that we have a very wide range. We have everything from the electronic expansion devices. The one that we have here is our ETS range, which is now available also for propane, for R290. But we also have multiple thermostatic expansion valves. The first one I wanted to show you here is the TU valve. It's our stainless steel valve, which has the application-specific bulb charge. It also ensures very high accuracy on the superheat setting. Besides that, it comes with multiple different connectors and piping lengths. If you want to go for a more cost-conscious if you're a more cost-conscious customer, then there is also the TD1 valve, which is also a thermostatic expansion valve with the application-specific bulb charge. Also ensures a high accuracy. And the one that I'm standing with here is in fact our prototype of the new valve that will be coming in 2021. So if you have a sharp eye, you are able to see what the difference is, or else contact one of our Danfoss colleagues to hear more about this one. Besides all of these different components, we also have the capability to make subsystems. So if you want to focus on making your display case and not the refrigerant circuit, then we can help you assemble the subsystems. But we can also, in our application centers, help you to optimize the refrigerant system, which is what we're working on the cases that you have here behind us. So that was all for the display case, and now I want to give the word over to you, Hans.
Thank you, Mathilde. So I have the honor to speak a little bit about the water side of the system today. I think what many people don't realize is that Danfoss, of course, has been a cooling company for many, many years, but almost just as long, Danfoss has been also in the field of heating. So we've been dealing with hydronic systems for more than 70 years in Danfoss. And what I'm standing next to here is a hydronic pump shunt unit. So this unit here is basically designed to provide water flow to the two cabinets here. It's designed specifically for this application. And we have engineers, hydronic engineers, that are able to design also your system. The specific system here, it has variable speed pumps to provide the flow to the system. And it also has the three-way pump shunt to make sure that the right temperature is always provided to the system. So the task of the pump shunt, of course, and the pump station is to provide the right flow and the right temperature to the system, to the cases. If you get too high a temperature, as what Stefan was mentioning before, too high a temperature and you will have pressure cutout on your condensing units, and too low a temperature and you may have trouble also getting liquid out through your expansion devices. So that's what we can do with the pump station. Of course, we can design that specifically for your application. The pump station here is controlled by the MCX controller. This is a programmable controller, so it can be programmed to specifically your unit. And we can help you to do that. So this means that you can control it to provide a certain head pressure. You can control it also to manage the dry cooler on the system. So managing that if, for example, the temperature is increasing, that you increase the fan speed, or if the temperature is decreasing, that you're also able to possibly bypass the dry cooler. But it also can be used to interface to adiabatic cooling systems, or to chiller system, or even to a heat pump system, or heat recovery type systems. So this is quite a powerful product, and it can also interface actually to the system manager. And if you don't have a system manager, a Danfoss system manager in your store, then it can also interface directly through its own built-in web server. So there are a lot of different options with the MCX controller. One of the biggest challenges that we've actually seen in these types of systems is that we have unbalanced systems. And what we mean there is that the water that's provided, the flow that's provided by the pump station will always take the path of least resistance. And to manage the flow, it's important to have pressure-independent balancing valves in the system. If the flow is all going through the nearest case in the store, then you won't get enough flow to the front of the store, to the cases at the front, and you will not be able to manage temperature in those cases, so leading to food loss. The balancing valve will make sure that every case gets exactly the amount of flow that it needs. So, and it's quite simple. So you need to know what is the nominal flow that you need to each case. You choose a valve size that meets that requirement, and then you set the flow rate to the percentage of the nominal flow of the valve. Then you will always get the flow that is required. We have some experience that shows that in these kinds of circuits, between 10 and 15% of the pumping power can be saved actually by using the pressure-independent balancing valves, the ABQN valve. Another thing that we can do with the ABQN valve is that we can put an actuator on. In this case, this is a Novacon actuator, and the Novacon actuator is actually quite smart. It has the ability to take a temperature input, also other types of inputs, and then control the flow rate based on that input. So you can actually, if you're defrosting your case and your condensing unit is shut down, then you can shut off the flow. In other cases, you may see that the temperature is low, and you can also reduce the flow rate, so thereby also providing additional energy savings, additional control features for your case. In very simple systems, where we don't have a lot of electronic controls, then we can use a purely mechanical control to ensure that the condensing pressure is maintained. So when the ambient temperature, when the temperature outside goes down, and you have low temperature on your water loop, then in some cases you need to make sure that you have enough pressure in the system to drive the refrigerant through the system and the oil through the system. So this is a water regulating valve. It's a WVO water regulating valve. It's completely mechanical and makes sure that you always have a minimum condensing pressure. And with that, I'll take it back to you, Mathilde.
Thank you very much, Hans. That was all that we had to present today. Don't forget about the Q&A session that is starting right after this one, where you can talk to the expert here behind me. Also, if you want more documentation on some of the products here, check out the link below this screen. And then there are multiple sessions going on today, so I can just recommend one of them, which is Making Sense of Data, the Alsense Cloud at 11:20. So please check that one out as well. And then thanks to you for joining today, and thank you to you as well for joining.